Hi, I'm Alix Paultre with Aspen Core, and I'm here today with Stefan Hauser. He's the Senior Manager of Product Marketing at Semikron. And, well, we're here at the Wide Bandgap show, so obviously we're here to talk about wide bandgap semiconductors. So welcome to the show.
Thank you very much.
Well, I'm really glad to have you here because Semikron has a wide bandgap play, but you don't make your own chips, correct?
Yeah, that's correct. We don't do our own silicon carbide or gallium nitride chips. But for us, that's actually a real advantage because that means we can freely select the chips that we think are the right choice for the customer and for the application. So we also focus then really on the power packaging and don't have to focus on the chip development. We can just select from the market whatever is available.
Well, and that makes a lot of sense, Stefan, because keeps you manufacturer agnostic. You don't have to worry about being specialty, tied into any one supply chain source. And as my audience knows, packaging is one of my big peeves. I think that, I recognize there are arguments to have a silicon carbide device in a TO220 package, but you're not going to really convince me very strongly. I think optimizing the packaging is the only way to get the true performance out of the device.
Absolutely right. When you go for a TO device package, you always have to think about how do I isolate the package from my heatsink. If you go for a power module, that is not the case because it always comes with a kind of isolation, right? Another important aspect is, of course, miniaturization. If you pack the complete topology, whether it's a 6-pack, it's a 3-level topology, it's a complete inverter with rectifier, whatever it is, into one power module, you will always work on a smaller space than you would need for TO devices.
Well, and power management is thermal management, right?
Correct. This is why you definitely want everything included. You want the isolation, and that means also a good thermal transfer included in the power module. So whenever you need to add something on a TO device to isolate it, it will increase the thermal resistance. That's definitely a problem. And silicon carbide, that is even a bit more critical because silicon carbide chips have a much higher power density coming from smaller chip size. So you have to be really careful to select the right materials for the isolation to make sure that the thermal impedance from the chip to the heatsink is good enough to get the best out of the chip.
Well, and that makes all the sense in the world. Because, well, you probably get it from your clientele. They have obviously different levels of packaging requirement. You know what I'm saying? In other words, some people are happy just with a better package. Some want the most optimum design possible. How much of your clients' requests are custom and how much can be satisfied with a general product?
Let's put it that way. I guess we have now about 25 power modules based on silicon carbide. That means hybrid silicon carbide, where we keep the IGBT and just exchange the freewheeling diode with the silicon carbide Schottky diode, as well as full silicon carbide, means also the switch is a silicon carbide MOSFET. I guess 80% of these 25 different modules originate from customer-specific requests.
Got it.
So this is, for us, first of all, generally speaking, a key to market success. But on the other hand, for silicon carbide, as the material is expensive, more expensive than silicon, will probably always be more expensive than silicon, at least in the power range we are talking, like 20 amps upwards. It is very important to optimize the chip selection. And this is a service that we can do to the customer, right? We get the application information from the customer and we propose a chipset, maybe even propose a package. Maybe the customer has already a preferred package. And then we start a discussion, and at the end, we usually have a customer-specific power module.
Got it. Now, and then you keep it for use for other clients as well, or is there any NDA type stuff there?
This really depends on the customer. So it can be freely available, as most of the modules are, but some, if the topology is very specific or might be patented, then of course the IP has to be protected. Then it can be also completely customer exclusive.
Excellent. Now, when you think about it, there's a lot of engineering obviously going into the product, but today the engineer also needs assistance in making sure that it's optimally installed. What kind of engineering support do you provide to the customer once they've taken it home?
So we have a very good and well-trained, very capable application team. And this application team, first of all, can help the customer actually with the chip selection, so these are the same guys, but then also help in the design of the system. That means how do we do the connection to the DC bus? How do we design actually the driver? We have our own driver modules, which we can directly sell with a power module, but also just assist the customer in finding the optimal one. And if you want to go one step further, we are not only supplying power modules, we can also think about stacks, which means you mount the power module on a heatsink, fans included, DC bus caps included, driver included, so that the customer just needs a controller in the end. And if this is not what the customer wants, then at least we can offer some kind of evaluation board, for example. So just to get a feel for the technology, evaluate new chipsets, new topologies, and then the customer can decide, hey, I go for this evaluation board on a series product, or I do my own one, which is maybe a little bit more optimized to the customer needs.
Well, yeah, and reference designs, evaluation boards, demo kits, they're critical today. I mean, you could have a chip that's superconducting at room temperature, and if you don't have a SPICE model and you can't explain the application space that it's good for, you'll get some business, but not if you explain the device, give the background, give the development assistance.
This add-on is expected today.
It's required. I mean, one of the things I'm fond of saying, the people who are good at making subsystems work for subsystems companies now. Today's engineer has to be an orchestra conductor. You have to be able to get all of these systems and you have to integrate them into an intelligent whole.
Yeah, right, correct.
So it's good to know that you've got support there out there for them to do such things.
Definitely.
Where do they go to get more information?
They go on our website, I would propose, www.semikron.com. And there you find all the context that you need to get more information on the modules. You get also the silicon carbide power module data sheets. You get information about our stack design and stack possibilities, which are actually globally distributed. It's also a nice thing. So we won't do a stack design in Europe and ship it to US, for example. We have our own design center there and also production there, just as an example. So that's also a very nice thing and comes very handy for customers worldwide.
Highly useful there. Excellent. Any last words for our audience before I let you go?
Yes, I think a main takeaway should be that we are actually teaming up with our customers to really find the optimal solution in terms of chipset, in terms of packaging for their application.
Well, thank you so much for coming and taking the time.
Thank you very much for having me.